In this tutorial, we will be discussing how to balance half reactions. Perhaps the easiest way to balance the equation of an oxidation-reduction reaction is via the half reaction method. This method involves treating on paper only the oxidation-reduction as two separate processes, balancing these half reactions, and then combining them to attain the balanced equation for the overall reaction. So the first thing you want to do is assign oxidation numbers to determine what is oxidized and what is reduced. Then write the oxidation and reduction half reaction separately. Balance each half reaction. For acids, balance the elements other than hydrogen and oxygen. Balance oxygen by adding H2O. And balance the hydrogen by adding H+. Balance the charge by adding electrons. Remember, I said this was for acids. Multiply the half reactions by integers so that the electrons gained and lost are the same. Add the half reactions, subtracting things that appear on both sides. Make sure the equation is balanced according to mass. In other words, the atoms. Make sure the equation is balanced according to charge. Alright, so let's go through this slowly, step by step. Consider the reaction MnO4- and C2O4 2-. First, we assign oxidation numbers. Because oxygen is always a -2 unless it's a peroxide, we can figure out manganese. So we have 4 oxygens. We have Mn plus 4 times the -2. Overall charge is a -1. Reduce this down and we find manganese is a +7. Go through the same steps for the next compound. We have 2 carbons and we have 4 oxygens, which once again is a -2. And the whole thing is a -2. Balance that out and it comes out to be a +3 for carbon. Manganese 2+ is easy. They give you what the oxidation number is by the ion charge. And then for carbon dioxide, we have carbon plus 2 of the oxygens, which is -2, with an overall 0 charge, which would make carbon a +4. So from this, we can tell that manganese is going from a +7 to a +2. It's becoming less positive. It's gaining electrons in this process. In fact, it gained 5 electrons. Gain electrons reduce. Grr. Carbon goes from a +3 to a +4. It lost 1 electron in this process. Leo, lose electrons, oxidized. Alright, so now we're going to break them up into separate reactions. Let's look at carbon first. It's going from C2O4 2- with a charge we said was a +3 to CO2 with a charge of +4. Once again, remember that it has actually lost electrons in this process, so it's been oxidized. Alright, first thing we want to do is balance the things that are not hydrogen or oxygen. That leaves us with carbon. We have 2 on the left and only 1 on the right. So we're going to use the coefficient of 2 to balance off the oxygens. From here, the oxygen is now balanced because we have 4 oxygens here and we have 4 here. Now let's look at the charge. We stated that it's losing 1 electron for every carbon. Because it's done it twice, we lost a total of 2 electrons. Now let's look at manganese. The manganese atom is balanced. We still have to deal with the oxygen. For every oxygen, we add that many waters. So we have 4 oxygens, so we're going to add 4 waters. Now we balance out the hydrogens. We have 8 hydrogens added since we added the waters. So therefore, we add hydrogen on the opposite side. Now let's take a look at the charges. It started off with a positive 7 and is going to a positive 2. Therefore, it's added 5 electrons in this process. That's where we get the number 5 from. Now evaluate the 2 half reactions together. To obtain the same number of electrons on each side, we multiply the first reaction by the number 5. We multiply the second one by 2. We want to know what number was the smallest number that's divisible by both 5 and 2, and that number is going to be 10. And that's how we got 10 here. Then we add these electrons together. Think of the arrow as an equal sign. Everything on the left here goes on the left here. Everything goes on the right goes on the right. The only thing that appears on both sides are the electrons. So we have 10 electrons here and 10 electrons here. So we're going to cancel those out. Hydrogens are only on one side. Everything else is only on one side, so we can't cancel anything else out. So we're done. That's the final reaction. Alright, so let's do this again. We have aluminum and copper reacting together. Let's figure out what the charges are first. Aluminum, since it's a metal by itself, is just 0, going to a +3. Alright, in this process, it lost electrons. It lost 3 electrons in this process. That means it was oxidized. Lose electrons, oxidized. Copper is going from a +2 to a 0. It gained 2 electrons in this process. Gain electrons, reduced. So the copper is being reduced. Now let's break up those compounds, or those reactions. Aluminum is yielding aluminum 3 plus aqueous. It lost 3 electrons, so we're going to put 3 electrons on the right, because that's what it was lost. It's going from a +2 to a 0, it gained 2 electrons. The next thing we want to do is figure out the smallest number that's divisible by both 2 and 3, and that number is 6. So, to get 6 on the top one, we're going to multiply it by 2. To get 6 on the bottom one, we're going to multiply that by 3. So we have 2 aluminum plus yields 2 Al3 plus and 6 electrons. And then with the copper, we find we have 3 Cu2 plus and 6 electrons yields 3 Cu solids. The electrons cancel, and that's the only thing that can cancel. Everything else is brought down. So 2 aluminum plus 3 Cu2 plus 2 Al3 plus and 3 Cu. Alright, let's try a little bit more difficult one. First, let's try to figure out what all the charges are. Let's break them up. We know the irons are going to go together, and we know the manganese is going to go together. So, Fe2 plus yields Fe3 plus. It's going from a +2 to a +3. It's becoming less negative, so that means it's losing electrons. In fact, it only lost 1 electron in that process. So that 1 electron is going to be on the right-hand side. Manganese we had to figure out what manganese is, and that's going to be a little bit more difficult. We have manganese plus 4 times negative 2, because oxygen's a negative 2 and the overall charge is a minus 1. So Mn minus 8 is equal to minus 1. So that means manganese here is a positive 7. Manganese here is a plus 2. Is becoming more negative. So, is actually gaining 5 electrons. If you didn't follow the more negative thing, here's the number line, here's positive 7, here's positive 2. It's getting closer to the negative side. So therefore it's gaining 5 electrons in order for that to happen. So I'm going to put 5 electrons on the left hand side. This one's a little bit more difficult. Up here on the iron one, the iron is balanced. There is no oxygens. There are no hydrogens. So I don't have to worry about balancing anything else but the charge, which we did. On the bottom one, we have oxygen to look at. We have 4 oxygens on the left and none on the right. In order to balance out the oxygens, I have to add 4 waters. Now I have hydrogens on the right and none on the left, so I have to balance that out by adding 8 hydrogens. So let's get a little bit more room here. We have Fe 2 plus yields Fe 3 plus 1 electron. And then with the manganese we have 8 H plus 5 electrons and MnO4 minus. On the right hand side we have Mn2 plus 4H2O. Alright, we need to find a way, find something that's divisible by both 1 and 5. I'm going to multiply this top one by 5. So 5Fe2 plus yields 5Fe3 plus and 5 electrons. That means I can cross out that top one. I can cancel out the 5 electrons and pull everything else down. Nothing else cancels, so I don't have to do anything else. And 5 Fe3 plus. And that is our balanced equation. And that's how you balance redox reactions via half reactions.